Chemistry 20. This is our 8th lesson in the chemical bonding unit. This is physical properties of ionic and molecular compounds. In this lesson, we will look at the physical properties of melting and boiling point, solubility, and electrical conductivity for both ionic and molecular substances. First is ionic physical properties. For an overview of the properties, you can click on this link to watch a short video. Melting and boiling points of ionic compounds. Ionic compounds have very high melting and boiling points because their intramolecular forces must be broken in order to melt or boil. That means we actually have to break the bond between the ions, between the Na and Cl. The bonds must be broken in order for these substances to melt and or boil. As we're saying, this requires a high amount of energy. Therefore, we can see in our picture, when we melt NaCl solid, we are actually breaking that crystal lattice structure and separating the ions. Solubility of ionic compounds. Ionic compounds are soluble in water, meaning they will dissolve. In order for a substance to dissolve in water, it must separate in water. Water molecules are polar, meaning they have a positive and negative side. They can be attracted to the individual molecules in an ionic substance and will therefore then pull them apart. We can see in our example, we have a cube of NaCl. When we put this in water, the water molecules will be attracted to the individual ions in the giant crystal lattice structure. The water molecules will then pull those ions apart and separate them. This is known as an ion-dipole interaction. Electrical conductivity of ionic compounds. Electricity requires ions, charged particles, to carry electrons through water. When ionic compounds are placed in water, they dissolve into their individual ions and therefore will conduct electricity. That brings us to physical properties of molecular substances. It's extremely important to know that when you boil or melt a molecular substance, you are not actually breaking the bonds between the atoms in the molecule. You are only separating the intermolecular forces between molecules. For example, if we think about H2O in its solid, liquid, and gas form, its chemical formula is still H2O. We are not breaking apart the atoms in the molecule. What we are doing is separating the intermolecular forces. If we consider solid ice, this form of H2O has the most intermolecular forces. And if we heat that substance, we are going to start breaking those intermolecular forces between molecules, and eventually we will get to a liquid state. If we continue to heat that substance and add energy, we will eventually break all of the intermolecular forces, separating all of the molecules, and we will then finally be in a gas state. Melting and boiling points of molecular substances. Molecular substances have relatively low melting and boiling points when compared to ionic substances. That is because we only have to break the intermolecular forces between molecules. It's important to consider the type of intermolecular forces present in that molecular substance, because the stronger the intermolecular forces between the molecules results in a higher melting and boiling point. Example number 1. Explain which substance, H2O, or CF4, has a lower melting point. Use intermolecular forces to explain your answer. Pause the video and attempt this example. Both CF4 and H2O have London dispersion forces. CF4 will be slightly greater as it has more electrons. But H2O is polar and will also have dipole-dipole forces. CF4 is nonpolar and will not have any dipole-dipole forces. And finally, H2O has hydrogen directly attached to a nitrogen, oxygen, or fluorine, so it will qualify for hydrogen bonding. CF4 does not have hydrogen bonding. Therefore, CF4 has less intermolecular forces, therefore will have the lower melting point. Solubility of molecular substances. Polar molecules are attracted to water molecules because water is also polar and they will dissolve. But non-polar molecules are not attracted to water and they will not dissolve. That brings us to the term like dissolves like. A polar substance will dissolve in water because water is also polar. But a non-polar substance will only dissolve in another non-polar substance. Remember, when we dissolve molecular substances, we are not breaking them apart into their atoms or ions. We are only separating them into individual molecules. A good example of a non-polar substance not dissolving in water is oil placed in water. That is because oil is non-polar and water is polar. When we look at our illustration, we can see oil will form at the top of water, and down below we have all the water molecules grouped together. This is representing that our substance is not mixing, it's not dissolving. That is because the only force of attraction present in this beaker is the force of attraction between water molecules. They will attract each other and group together. As a result, they will force the oil to separate at the top of the beaker. Electrical conductivity of molecular substances. Molecular substances dissolve into individual molecules. They do not dissolve into ions. Therefore, they will not conduct electricity. Example number 2. Rank the following molecules with respect to boiling point and determine the solubility of each substance in water. Pause the video and attempt this example. And our order of boiling points is first, our highest boiling point is IrO2. This is because it's an ionic substance and they have the highest melting and boiling points. Next up is NHO, and that is because this molecular substance has hydrogen bonding, the strongest type of intermolecular force. Then we have to move forward with any other polar substances. CH3Br is polar. It has dipole-dipole forces, so it will have the next highest boiling point. And finally, that brings us to our last two substances, which are both non-polar. When we are considering the boiling point of non-polar substances, the substance that has the larger structure, has the more electrons, will have the more London dispersion forces. Therefore, the next highest boiling point will be C3H8. And finally, our lowest boiling point will be CH4. If we consider the solubility of each substance, we are looking for substances that are ionic and polar. Those substances will dissolve in water. Therefore, CH3Br is polar. It will be soluble in water. CH4 is nonpolar, therefore it will be insoluble in water. IRO2 is ionic, it will be soluble. NHO is also polar, therefore it will be soluble. And finally, C3H8 is nonpolar, therefore it will be insoluble in water. Consider the following. Ionic compounds have the highest melting points. Covalent compounds have lower melting points. Ionic compounds separate into ions, while molecular substances separate into individual molecules. Moving forward, we will explore chemical nomenclature.